Earth's strongest ocean current could slow down by 20% as Antarctica melts. Timur Sohal and colleagues write, following clockwise around Antarctica, the Antarctica circumpolar current is the strongest ocean current on our planet. It's 5 times stronger than the Gulf Stream and more than 100 times stronger than the Amazon River. Can you imagine? It forms part of the global ocean conveyor belt connecting the Pacific, Atlantic, and Indian Oceans. The system regulates Earth's climate and pumps water, heat, and nutrients around the globe. But fresh, cool water from melting Antarctica ice is diluting the salty water of the ocean, potentially disrupting the vital ocean current. Our new research suggests that Antarctic computer current will be 20% slower by the year 2050 as the world warms, with far-reaching consequences for life on Earth. And why should we care? The Antarctic circumpolar current is like a moat around an icy continent. The current helps to keep the water warm at bay, the warm water at bay, protecting vulnerable ice sheets. It also acts as a barrier to invasive species such as southern bull kelp and any animals hitching a ride on these rafts, spreading them out as they drift towards the continent. It also plays a big part in regulating Earth's climate. Unlike better-known ocean currents such as the Gulf Stream along the United States East Coast and the Kuroshio current near Japan and the Agulhas current off the coast of South Africa, the Antarctic circumpolar current is not so well understood. It's partly due to its remote location, which makes obtaining direct measurements especially difficult. Understanding the influence of climate change, ocean currents respond to changes in temperature, salt levels, wind patterns, and sea ice extent, so the global ocean conveyor belt is vulnerable to climate change on multiple fronts. Previous research suggested one vital part of this conveyor belt could be headed for a catastrophic collapse. Theoretically, warming water around Antarctica should speed up the current. It's because density changes and winds around Antarctica dictate the strength of the current. Warm water is less dense or heavy, and this should be enough to speed up the current, but observations to date indicate that the strength of the current has remained relatively stable over recent decades. This stability persists despite melting of surrounding ice, a phenomenon that has not been fully explored in scientific discussions in the past. And what we did? Advances in ocean modeling allow a more thorough investigation of potential future changes. We use Australia's fastest supercomputer and climate simulator in Canberra to study the Antarctic circumpolar current. The underlying model, Access OM201, has been developed by Australian researchers from various universities as part of the Consortium for Ocean Sea Ice Modeling in Australia. The model captures features others often miss, such as eddies, so it's a far more accurate way to assess how the current strength and behavior will change as the world warms. It picks up the intricate interactions between ice melting and ocean circulation. And this future projection, cold, fresh meltwater from Antarctica migrates north, filling the deep ocean as it goes. This causes major changes to the density structure of the ocean. It counteracts the influence of ocean warming, leading to an overall slowdown in the current of as much as 20% by the year 2050. Far-reaching consequences. The consequences of a weaker Antarctic circumpolar current are profound and far-reaching. As the main current that circulates nutrient-rich waters around Antarctica, it plays a crucial role in the Antarctic ecosystem. Weakening of the current cold that could reduce biodiversity and decrease productivity of fisheries that many coastal communities rely on. It could also aid the entry of invasive species such as southern bull kelp to Antarctica, disrupting local ecosystems and food webs. A weaker current may also allow more warm water to penetrate southwards, exacerbating the melting of Antarctic ice shelves and contributing to global sea level rise. Faster ice melting could then lead to further weakening of the current, commencing a vicious spiral of current slowdown. And this disruption could extend to global climate patterns, reducing the ocean's ability to regulate climate change by absorbing excess heat and carbon in the atmosphere. While our findings present a bleak prognosis of the Antarctic circumpolar current, the future is not predetermined. Concerted efforts to reduce greenhouse gas emissions could still limit melting around Antarctica. Establishing long-term studies in the Southern Ocean will be crucial for monitoring these changes accurately. With proactive and coordinated international actions, we have a chance to address and potentially avert the effects of climate change on our oceans. And the author thanks polar climate senior researcher Dr. Andreas Klokker from the Norwegian Research Center and Bjerknes Center for Climate Research for his contribution to the research here, and Professor Matthew England from University of New South Wales, who provided the outputs from the model simulation for this analysis. This is from the conversation by Taimur Sohail, postdoctorate researcher, School of Geography, Earth and Atmospheric Sciences, University of Melbourne, and by Data Gayan, ARC Future Fellow and Associate Professor, Mechanical Engineering, University of Melbourne, from Science Alert. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.